As we continue to learn more about logic and reasoning, let's look at some conditional statements. Your learning objectives for this section are to identify the hypothesis and conclusion of an if-then statement, and to write the converse, inverse, and contrapositive of an if-then statement. As you'll notice from the top here, an if-then statement is sometimes referred to as a conditional statement. An if-then statement or conditional statement is a statement with a hypothesis followed by a conclusion. It looks like this. If this happens, then that will happen. This portion here after the if is called the hypothesis, and the portion after the then is always referred to as the conclusion. Again, the hypothesis is the first or if part of a conditional statement, and the conclusion is the second or then part of a conditional statement. The conclusion is the result of a hypothesis. That's really important to know. The conclusion is the result of a hypothesis. If-then statements might not always be written in the if-then form, however. Look at these. I'll wash the car if the weather is nice. I'll be a millionaire when I win Monopoly. All equiangular triangles are equilateral. Those are all conditional statements, but they're not written in if-then form. So, I'll wash the car if the weather is nice becomes, if the weather is nice, then I will wash the car. Do you see how we took this original statement and turned it into an if-then statement? I'll wash the car if the weather is nice is actually, if the weather is nice, then I'll wash the car. I'll be a millionaire when I win Monopoly. If I win Monopoly, then I will be a millionaire. And all equiangular triangles are equilateral becomes, if a triangle is equiangular, then it is equilateral. So again, as you see, there are some times where you're going to have to think a little critically about how to turn these statements into if-then statements. Look at the first statement again. If the weather is nice, then I'll wash the car. This can be rewritten using letters to represent the hypothesis and the conclusion. Now the statement is, if P, then Q. We always use P for the hypothesis, and we always use Q for the conclusion. Again, P stands for hypothesis, and Q stands for conclusion. An arrow can be used in the place of the if-then. So this here reads, if P, then Q. If P, then Q. We can also make negations, a negation, or knots of P and Q. The symbolic version of P is, well, I don't know how to say that, but not P, not P. So this is a negation or not. So this little tilde here, which I've colored yellow, makes this P actually say not P. So this would read, the weather is not nice, or I won't wash the car. Again, it makes the original statement the negative version of that statement. Using these nots and switching the order of P and Q, we can create new statements. Let's first look at a converse. You can create a converse by flipping the hypothesis and the conclusion. So you see here, I have my conclusion first, then my hypothesis. So if my conclusion, then my hypothesis. So if the weather is nice, then I'll wash the car becomes, if I wash the car, then the weather is nice. We can also make what's called an inverse. An inverse is made by negating the conditional statement. Remember, negating is like not, putting these symbols in front of our statements to say the opposite of, or the negative of, I should say. So, if the weather is nice, then I'll wash the car becomes, if the weather is not nice, then I won't wash the car. this is the inverse of my original statement. Lastly, contra positives. We make a contrapositive by flipping and negating the original conditional. So you flip it and negate it. So we have the conclusion first, followed by the hypothesis, and they're both negative. So if the weather is nice, then I'll wash the car becomes, if I don't wash the car, then the weather isn't nice. This is both flipped. I have flipped my hypothesis and my conclusion, and I've also made them the not version of themselves. If I don't wash the car, then the weather isn't nice. If the if-then statement is true, then the contrapositive is also true. This is a good way to find out if our if-then statements are true. The contrapositive is logically equivalent to the original statement. The converse and inverse may or may not be true. But a good way to see if your original conditional statement is true is look at the contrapositive. If the contrapositive is true, then the original if-then statement is true as well. Lastly, let's look at biconditional statements. A biconditional statement is when the original statement and the converse are both true. So you see here my hypothesis and my conclusion. So if hypothesis, then conclusion. And of course the converse, you just flip the hypothesis and conclusion. So now it reads if conclusion, then hypothesis. So a biconditional statement is when both of these statements are true.